Today we are going to work on prime factorization. Now that you have a stronger concept of what the difference between prime and composite numbers, we're going to be able to break down composite numbers into prime numbers. What that means is taking a composite number like 24 and breaking it down into a bunch of numbers that you can multiply to get 24. But each of those numbers that you can multiply will be prime numbers. Why we need to do that is the better you can understand prime factorization, the more you're going to understand greatest common factor and least common multiple. And when you understand those two concepts, you're going to have a stronger base for fractions that is huge for 6th grade. When we do prime factorization, there are two ways that we can approach this. We can either use a factor tree, which is method number 1 here, or we can use dividing by prime number. For this lesson, we're going to concentrate on one method, and that is on the factor tree. If you are comfortable using by prime numbers by looking at the example, feel free to use it. But for today's lesson, we are going to concentrate on factor tree and breaking down composite number to a group of prime numbers in the end that you can multiply together. So to find out how to do a prime factorization of a composite number, you will need to go to lesson number 3. In this case, we're going to start with this is how we take a composite number like 24 and change it to factors of prime numbers. We're going to use the factor tree method, and the reason it's called a tree is it's going to visually display itself and look like a tree. You start by putting the composite number on the top. In this instance, the number is 24. And then what we're going to do is put 2 branches, one here and one here, underneath it. What goes here and here are the 2 numbers that you can multiply to get 24. They're like your array boxes. So thinking about it, you want to use any set of numbers other than 1 in itself. So we can use 2 times 12. We can use 8 times 3. You can use 6 times 4. And of course, you can use 12 times 2, 3 times 8, 6, 4 times 6. So we're going to use any one of these sets because in the end, since we're changing them to prime numbers at the end, it won't matter. You're going to get the same answer. So in this case, I think I'm going to use 6 times 4. So I'm going to erase the other 2 so it doesn't get me confused and concentrate that. So to change 24 to a prime set of prime numbers, I'm going to take the 6 and put it right here. And I'm going to put the 4 and put it right here. I'm just not going to put the multiplication sign. And what I'm going to do is check, is 6 a prime number? Well, it's not a prime number because I can think of other numbers that will multiply into 6 other than just 1 times 6. 4 is not a prime number because I can think of other numbers that I can multiply to get 4. Since they're both not prime numbers, what I'm going to do is put 2 branches underneath each one. That means I got to keep going. I've got to find some numbers. I'm going to keep multiplying to find some numbers until they're prime. Now I go to 6. I have to think of what numbers can I multiply to get 6 other than 1 times 6. Well, I know 2 times 3 is 6. And so I'm going to go through my checking steps again. Is 2 a prime number? Well, 2 is a prime number because there's no other set of factors that I can multiply together to get 2. 1 times 2, 2 times 1 are my only arrangements. And since it's a prime number, I'm going to circle it. That circle makes the branches stop. I either put a circle or I put branches. In this case, I put circle. That means 2 is a prime number. I cannot factor it out anymore. Now I'm going to go to 3. Is 3 a prime number? It is a prime number. There are no other set of numbers I can think of or an array that I can build other than 1 times 3 and 3 times 1. Since that's the only one, that's a prime number and I'm going to circle it. And that stops my branches from growing too. Now I'm going to go to my other set of number here, the 4. So what set of numbers can I multiply to get 4, other than 1 times 4 and 4 times 1? I know I can do 2, let's use black, 2 times 2. And since 2 over here is a prime number, this 2 over here has to be a prime number too. And so since they're prime numbers, I'm going to circle it, and it stops the branch from growing. And that obviously is a prime number 2. That stops the branches going. Since I have no more numbers to keep going, that's my final product. So the way I write this is this. I'm going to write it in order. I got 1, 2 here, 1, 2 here, 1, 2 here. That's 3 2s. So I'm going to go 2 times 2 times 2. Then I'm going to multiply the 3 times 3. This all is the prime factorization for 24. If I wanted a shortcut to write this over here, I wanted a shortcut to write this over here, I can do exponents. And that's simple to do. And I can show you really quick. All I know is, all you have to do, if you can understand it, is take the 2's, and since there's 3 of them, I'm going to write 2 and a small 3 that shows I wrote it 3 times, times 3, and I only wrote that 1 time, so I'm just going to keep that as that, 2 to the 3rd. This is the exact same as this. This is just this one over here is a shortcut. But if you don't want to do that, you don't have to. You just need to understand the prime factorization.